In order to determine the force exerted at the smooth surface at location A and B, if the tensile force in the bolt GH is of 300 Newton, we can figure out these support reactions by developing our free body diagram of the member G, D, and C and listed down the external load of 300 Newton as well as the support reactions at pin joint and C and D as well, whereas also identifying the distance between these 2 points that will be required to develop our moment expression. So to start, our member DE is a two-force member, meaning that the force will be acting along the axis of the member DE, which can be represented by FGE, that is making an angle of 60 degrees with respect to the horizontal axis. Now for point C, since it is a pin support, I will have two support reactions CX and CY as the motion is restricted along the horizontal and vertical direction at the pin. Now to calculate our FTE, we can start by applying our summation of moment at point C equals to 0, as it will eliminate my CX and CY and I will only have one unknown of FDE. Now to calculate the moment of FDE, first of all we need to resolve it along its x and y component by taking the cos 60 function and sin 60 function. Now the horizontal component is going to create our clockwise moment with a moment arm of 0.25 meter, whereas the vertical component is making also a clockwise moment with a moment arm of 0.05 meter. Finally, I have the external load of 300 Newton that is also creating our clockwise moment. Simplifying, we have the value of FTE as 534.7 newtons. Next, let's go ahead and analyze our segment BEA so that we can resolve our support reaction at D and A. Since we have the smooth surface, the support reaction will be always normal to the surface. So for point B, it will be in the horizontal direction, whereas at point A, it will be acting vertically downwards. Whereas the force in the member DA is acting along the axis of the member, that is making an angle of 60 degrees with respect to the horizontal axis. Now, once we have the free body diagram, we can go ahead and start applying our equilibrium equation of summation of forces along the horizontal axis equals to 0. Simplifying, we get our value of Px as 267.35 Newton, whereas applying summation of forces along the vertical y-axis equals to 0, and simplifying, we get the value of force exerted at the smooth surface at point A equals to 463 newtons.